I, Professor Sambhaji Gaikwad, on behalf of Institute Rajiv Gandhi Institute of Technology and Department of Mechanical Engineering, welcome you all to AICTE AQIS sponsored online short-term training program on recent trends in energy management and audit. As is our culture, let us commence this session with invoking Goddess Knowledge Saraswati by reciting Saraswati Vandana. I request the technical team to play the audio. Now that we have paid respect to the goddess of knowledge, I would like to introduce you to our institute. MCT Rajiv Gandhi Institute of Technology is a leading technological institute in Mumbai, Maharashtra. Established in 1992, the institute is located on the shoreline of Arabian Sea. The institute offers 5 UG courses in mechanical, EXTC, IT, computer and instrumentation engineering. It also offers 3 PG courses in mechanical, EXTC and computer engineering and 3 PhD courses in mechanical, EXTC and computer engineering. I would now request the technical team to play the video of our college.
शेअर करायला बोलले का
would now
Sir, hand over to you,
request,
sir.
I would now request Head of the Department of Mechanical Engineering, Dr. R.V. Kale, to brief us about the STTP.
Good morning to all. Today's guest and the keynote speaker, Mr. Suhas Patil sir, Additional Vice President at Adani Electricity Mumbai Limited, Dahanu Thermal Power Station. Our Honorable Principal, Dr. Sanjay Bukade sir, our Vice Principal, Dr. Sanjay Deshmukh, the co-coordinator of STTP, Professor Gaikwad, and the organizing committee consisting of Professor Mangrulkar, Professor Poddar, Professor Panaskar, Professor Kaur, Professor Ashwini, all the staff members and dear participants. Today we are starting our phase 3 of short-term training program on recent trends in energy management and audit. The speciality of this phase 3 is that we have most of the speakers from Dahanu Thermal Power Station. Dahanu Thermal Power Station, as you may be knowing, they conduct a 3-day training program on energy audit, for which they charge an handsome amount. We are fortunate to have the speakers who normally participate in that energy audit module of DTPS Dahanu. We have almost all the speakers for this phase 3. Dear participants, you have been cooperating with us so far. I would urge you all to remain present throughout for this phase 3 of the STTP. Thank you very much. Over to you, Gaikwad sir.
Thank you, Dr. R.V. Kale, sir, for your words of wisdom. Our chief guest and speaker of today's session is Mr. Suhas Patil from Adani Power. He is working as an additional VP, Maintenance Planning and Operation Efficiency. His industrial experience includes erection, commissioning, operation and maintenance in the thermal power plant and energy auditing and energy conservation activities in the thermal power plant since 1991. He has been involved in erection, commissioning, operations, energy efficiency and overhauling activities of 250 megawatt, 300 megawatt and 600 megawatt steam turbine, solar plant and its auxiliaries. He was associated in stabilization of world's first and largest 125 megawatt concentrated solar project based on CLFR technology. I welcome you, sir, and thank you for joining with us today. I request you to enlighten us with your words of wisdom. Hello, over to you, Patil, sir. Sir, left side.
Amol sir?
Hello.
Amol sir, am I audible?
Yeah, sir.
Good morning and warm welcome to all the participants who are connected through this virtual platform. And first of all, sorry for the delay in starting or this because of some technical snag at our end. And now thanks to the technology due to which we have been able to keep our keep on our learning even during this pandemic. Because of this virtual platform, we have not stopped our learning. And now I will start my presentation. And there is one request: please keep your all mics on mute mode, and so that to avoid any disturbance. And at the end of the presentation, we can take question and answer sessions. Is it okay, Amal sir?
Yes, sir. But the presentation is not visible.
Yes, sir. Yes, sir.
Okay. So this is the snapshot of our Adani Dahanu thermal power station. Now my flow of presentation will be like this.
Sir, presentation is not visible, sir, on screen.
Not visible.
Yeah, yeah. Not visible.
विजय, ये शेयर नहीं हो रहा है रे प्रेजेंटेशन, थोड़ा एक बार देखना वीएन से ले. हाँ बघ ना आता एकदा, जस्ट मध्येच ब्रेक झालंय. हाँ मग कसं करणार आहे? ठीक आहे कर.
हेलो पाटिल सर.
आता येतोय आवाज?
हा येतो. स्क्रीन पण विजिबल आहे.
स्क्रीन विजिबल आहे का?
येस येस.
ठीक आहे, ठीक आहे. No worries. Okay. Sorry for the interruption. And now my flow of presentation will be like this: plant profile, energy scenario, energy management system, efficiency control, and then efficiency based maintenance. First of all, I will take you through some slides wherein we will have a basic profile of Dahanu Thermal Power Station, which supplies electricity to financial capital of India, that is Mumbai. This plant is well connected by Western Railway and National Highway 8, and it is around 128 kilometers from Mumbai. And this plant is surrounded by two natural creeks, and sweet water requirement is fulfilled from the Surya Dam, which is nearby 32 kilometers from our plant. This is the aerial view of our plant, wherein you can see the plant situated in between two natural creeks. One is the Sauta and another is the Dandi. Major water consumption is catered through seawater, mainly required for the condenser cooling, and only the sweet water requirement is fulfilled from the Surya Dam, which is required for our normal day-to-day drinking and service water, and mainly for the steam generation required in the boiler. This is the land allocation for the plant, ash disposal, and the colony. This picture shows the sea change in our site condition before and after plant installation. It was totally a marshy reclaimed land, and it is given by the Maharashtra government for the on the lease of 99 years. And the top photo you can see, this is the Dahanu Thermal Power Station as on today, and it is one of the best run power plant in India. And this right side indicates the last 20 years average plant performance, which clearly shows the best reliability and availability of plant with efficient key performance indicators like our auxiliary power consumption, specific oil consumption, heat rate, etc. Here I would like to mention that heat rate is the ultimate performance indicator of any thermal power stations. So lesser this heat rate means better is the performance of our power station, any power stations. This 2290 kilocalorie per kilowatt hour is our average heat rate of our last 20 years. And here I would like to mention that even after 25 years of our plant operation, because this plant was commissioned in 1996, our heat rate is only 2% more than the design value. And our DTPS has achieved more than 100% plant load factor for 9 consecutive years in the past. Amal sir, is it audible now?
Yes, sir. Yes, sir.
Our plant is world's first power plant who implemented ISO 50001, that is energy management system. And this shows our commitment towards energy efficient plant operation and thereby sustainable power development. Our all business processes are integrated through enterprise resource planning, that is SAP. And the plant has been established a comprehensive fuel management system in view of logistic, economics, and O&M challenges and environmental issues. Because our plant is situated at our load center, that is Mumbai, but our fuel is, that is coal is our primary fuel that we bring from the Chhattisgarh, which is around 1200 kilometers from our plant. So over the period, we have started importing the coal from the Indonesia, Australia, and thereby we are using that blended coal with Indian and imported coal so as to limit our environmental emission because Dahanu is coming under eco-fragile zone declared by the Supreme Courts. And even our plant is certified for the ISO 14,000, that is mainly for the environmental standards. So we need to show continual improvement over the periods. This is the energy efficiency vision of our Adani Group. Mainly, Adani Group is interested in supercritical technology for efficient operation of our thermal power stations. So everybody may be aware that mainly thermal power generation is based on the Rankine cycle. And if you increase your operating pressure and temperature, definitely there is an increase in the efficiency and thereby efficient operation of any power stations. So nowadays we are mostly going for the supercritical technology of our upcoming plants. And our vision is we're the world's largest solar power company by 2025 and will be the biggest renewable energy firm by 2030. And we use the technology to save energy, improve efficiency, and contribute to building a sustainable business mode. We have adopted system approach to all our business processes. DTPS is certified for 10 different ISO certifications for quality, safety, environment, information security, social accountability, social responsibility, asset management, and energy management. Also, our coal testing lab is Enable accredited one. And through this system approach, we have been able to continually improve in all our processes. So now we'll go for the energy scenario. Everybody knows energy is one of the major input required for any economical development. And it's a critical importance mainly in the developing countries like India because of the ever increasing energy demand. And for fulfillment of these energy demands, it requires the huge investment. Ratio of energy demand to GDP is high. It clearly reflects the energy dependence and strong influence of energy on the GDP growth. And what is energy security? It is nothing but the uninterrupted availability of energy source at an affordable price. And the main aim of the energy security is to reduce the dependency on the imported energy sources. Because at present we have ample amount of coal, but we are mainly dependent on the other countries for the oil as a resource. So there are various strategies adopted to meet the challenges of this energy security, like diversification of energy supply sources, increased capacity of fuel switching, development of renewable energy sources, energy conservation, and energy efficiency. Many of the people may be thinking that what is difference between energy conservation and energy efficiency? Definitely the result of both are same, that is saving in energy. But here is the basic difference between energy conservation and energy efficiency. Here I would like to quote that energy conservation is mainly dependent upon the behavior of an individual, that is human based, like switching off the lights when not in use of air conditioners with 24-degree setting, use of natural lights, reduction in idle running of vehicles, equipments, or any appliances. These are some of the examples of energy conservation, and it is all depends on the behavior of an individual. Whereas energy efficiency, it is totally depend upon the technological improvement. For example, use of CFL in place of incandescent lamp, use of LED in place of CFL, use of high efficiency motors, use of star rated appliances. All these are the examples of technological improvements, and because of this, there is energy saving. Both the results of conservation and energy efficiency is the same, that is saving in energy. This picture shows the importance of energy efficiency and energy conservation. It is never too late to practice energy honesty and efficiency. Otherwise, this history will repeat itself. In 1800, there was a candle age. Over the period in 1900, there is a invention of incandescent lamp. In 2000, we have switched over to CFL. In year 2020, we have switched over to LED. If we not taken care of energy efficiency, then in 2050, again there is a chance of again candle age. So there is a importance of energy conservation and energy efficiency. So all must agree over this. Now we'll see what is energy audit. First of all, we'll see what is the need of energy audit. It is nothing but understanding the energy usage in any industry, in any institute, including your educational institute. What is the energy usage in the area wise of any industry institute is required. It helps in identifying the areas where waste is occurring and where there is a scope for improvement. Many times it is quoted that use but don't misuse. This applies very specifically for this energy. Focus on the variations which occurs in the energy cost, and mainly we need this energy audit to decide on the appropriate energy mix, then identify the energy conservation technologies, and if any retrofit for the energy conservation equipments due to technological improvements. This is the need why we require the energy audit. And what is energy audit? It is nothing but the verification, monitoring, and analysis of energy use throughout any organization. And based on this energy audit, there is a submission of technical report which contains the recommendations for improving the energy efficiency, and that too with the cost benefit analysis of all these recommendations. Then it includes the payback period and what will be the action plan over the period to reduce the overall energy consumption in any industry or in any organization. Then there are the type of audits. The type of the audits depends upon the function and type of the any industries. Second one is the potential of cost reduction is desired by any organization or any management. It depends upon the in depth how much you are going to analyze or how much you are going to invest on this. It can be classified in two types. One is the preliminary audit or detailed audit. Preliminary audit methodology we'll see. Preliminary audit is nothing but a walkthrough audit. And it is a relatively a quick exercise which establishes the energy consumption pattern in any organization. It will estimate the scope for saving, mainly identify the most likely and the easiest areas for attention, that is especially no cost or low cost improvements and savings. Here we can say they are the direct improvements. Identify areas for more detailed study and measurement, means it identifies the areas which requires detailed on energy audit to come out with the scope for the improvement and thereby energy saving. And in this preliminary energy audit mainly uses the existing or easily obtained historical data available with any organization. So this is normally called as a walkthrough audit. And now we'll see detailed audit. In detailed audit, there are three phases. First is the pre-audit, second is the audit phase, third is the post-audit phase. Main information to be collected during this audit is the energy consumption by type of energy. Type of energy means there are different type of energy: primary energy, secondary energy. Primary energy is nothing but your coal, oil. Secondary energy means your steam, electricity, compressed air, etc. It requires the information about the consumption patterns by type of energy. Then material balance data. What are the materials used, raw materials? What is your immediate or final product? Recycled materials, production of byproducts, etc. Energy cost and tariff data. Process and material flow diagrams of each processes. Generation and distribution of site services like compressed air, steam required for various processes throughout the organization or throughout the industry. Sources of the electrical supply, whether it is electricity supplied from the grid or it is a captive, or you can say self-generation by that industry only. Then potential for fuel substitution and process modification. In due course of time, we will see what is fuel substitution and why it is important in this energy management. These are the data required for the energy audits, means what type of technology is used and what type of processes are used and the equipment details. Because over the period, there is major development in various technologies or equipments, so that based on this energy audit and cost benefit analysis, it is recommended to switch over to the new processes or new technology or new equipments. Then next one is the capacity utilization. Then many people may be asked that why capacity utilization is more important, because it's a simple example. There are many energy used irrespective of your plant output or any output of any industry. Like in simple example, I will say your plant lighting or air conditioning. These are some of the basic examples. They are the must run, or you require to have irrespective of your capacity of or your output of any industry. Means whether your plant is operating at 100% or if your plant is generating only 50% output, there are some must run equipments that requires energy. So your auxiliary power consumption is always high when your plant is operating at lower load because of the must run equipment or energy usage. Then amount and type of input materials used. What type of materials you are using? Here I will quote one example. We are using coal as a main fuel in our boilers. If we are using coal with higher ash percentage, then most of the students are from mechanical, they will be well aware that the air input required in the boiler for the combustion will be high. But on the other hand, your output will be the same output. For that handling of the air or flue gas, you will require the higher fan loadings, and which ultimately increase your auxiliary power consumption. Then what are the water, fuel, steam, energy consumption throughout the plant? Other inputs such as the compressed air, cooling water, etc. Quantity and type of waste generated. Percentage rejection, reprocessing, and efficiencies and yield. These are the main data required in your detailed energy audit process. And ultimately, we should come up with the area for improvements and the recommendations required to reduce our overall energy consumption. Why it is required, that we will see in our energy management process. And benchmarking of our energy performance. This is a powerful tool for performance assessment. It is just nothing but a logical evaluation of avenues for improvement. Here we can compare one-to-one similar industries with various performance parameters, and we should come to know where we have to improve and how to improve. For example, we have quoted two examples. Kilocalorie per kilowatt of power produced. We can compare our heat rate. This is kilocalorie per kilowatt is a heat rate of any power station. So we can compare with the other similar industry or similar power plant, and we can compare our performance. This is process is nothing but the benchmarking process. You must be aware that kilocalorie per kilowatt means how much thermal energy is required to generate one unit of electricity. So lesser this amount, better is the performance of your power station. So always we benchmark with the other power stations, and we find out the various best practices adopted in other plants so that we can replicate in our own organization so as to reduce this heat rate. For example, in refrigeration or air conditioning, what is the kilowatt per ton of refrigeration? You can compare with other utilities. How much the kilowatt per ton of Blue Star supplied refrigeration? What is supplied by the Voltas? And you can come up with the deviations. Kamal sir?
Yes, sir.
Am I audible? No?
Yeah, audible, sir.
Okay. I'll take. This is one of the benchmarking example of our power station, Dhanu power station. This left side figures are the targets or the national benchmark, you can say. 2450 is the heat rate, and 8.5 is the percentage auxiliary power consumption of our own plant for generating our electricity. And on the right side, this is the targets given by MERC, that is regulatory body existing in Maharashtra, that is Maharashtra Electricity Regulatory Commission. They give us the targets for the heat rate as well as the auxiliary power consumption. And if you compare all these targets with the middle figures, that is 2263 is our heat rate, that shows our plant performance, because our target is 2450 and our heat rate is 2263, means we are consuming significantly less energy to generate 1 unit of electricity. This clearly indicates the efficient operation of our power station. And in terms of auxiliary power consumption, our target is 8.5%. That means we are utilizing 8.5% of our generated power to our own auxiliaries, like various fans, pumps, cooling water pumps, etc., for generating our 250 megawatt. Here also you can see 8.5 is our target value, but our auxiliary power consumption is 8.157%. And yellow figures are including FGD. That is, the FGD is nothing but the flue gas desulfurization unit, which is imposed by the Supreme Court because Dahanu is coming under eco-fragile zone. And that target is 9.75, whereas our actual figure is 9.581. This is the benchmarking with our peer companies in the last year. And these are the various parameters, key performance indicators, you can say, of any power station, that is availability, plant load factor, loading factor, auxiliary power consumption, specific oil consumption, DM water makeup, and heat rate. Heat rate is the ultimate performance indicator of any power station. These are the various peer companies with which every year we are comparing our performance in all these key performance indicators. And accordingly, we modified or we make in our operational changes so as to improve on continuous basis. Then we'll see the matching energy used to the requirement. This is nothing but the mismatch between equipment capacity and user requirement, and this leads to energy loss. Most of us may be aware that every design engineer takes into consideration of worst case design, and in day-to-day operation, optimization is the role of energy manager. So normally there is a sufficient margin is taken by any design engineers during design of any equipment, but in our day-to-day operations, because of that, there is always a energy loss. I can quote one example that matching energy use of requirement, because of this extra margin, in many times we need to eliminate, we need to throttle the pump discharge to match with our requirement. So in that case, operation optimization can be done either by throttling, by impeller trimming, or by installing the variable frequency drive to that motor. So accordingly, we will modify the process or equipment so as to reduce the energy use by that particular equipment. This is called as a matching energy use to the requirement as per your process, because most of the equipments are standard one, like motors, fans, and according to our process requirement, we should carry out some modifications so as to reduce the energy usage in your industry. Then we'll see what maximizing system efficiency. Once the energy usage and resources are matched, next step is optimization through best O&M practices and your judicious technology adoption. Here are two examples I have quoted. Adopt combustion controls for maximizing combustion efficiency and maximize condenser recovery. Here I will say, you may be aware that in boiler, for your coal consumption, you require the air. Air means actually oxygen. So whenever there is a deficiency of oxygen or air, then there is always a incomplete combustion, and which leads to the losses. Or in other way, if you increase your airflow to the boiler, then there is a complete combustion, but there is an excess air, which ultimately loads your fans to handle the flue gas. It will increase your auxiliary power consumption. So we should optimize in such a way that there should not be incomplete combustion, or there should not be any excess air to handle these gases, which ultimately increases our auxiliary power consumption. So for that, in our case, we have installed one CO analyzer, at our chimney, that is means at the outlet of the boiler. This CO indicates type of the combustion happening in the boiler, and based on this CO monitoring, either we should modulate our air in the boiler. And fuel and energy substitution. Why it is required? Because substituting existing fuel and energy with more efficient and less cost or less polluting one. I will say two examples for fuel substitution. LPG in place of soft coke in residential use. This is one of the fuel substitution example. Or replacement of light diesel oil by low stock high sulfur. Mainly this is used as a secondary fuel in boilers. These are some examples of the fuel substitution. And for energy substitution, the replacement of electrical heaters by steam heaters, because they are not efficient one. Or replacement of steam heaters by solar heaters. These are the examples of energy substitutions. Now we'll see energy management system, its a role and it's a need in today's energy scenario. Why it is required and what exactly it is. It is nothing but a strategy of optimizing energy using systems and procedures. Means systems and procedure to reduce overall energy requirement per unit or output. Or in other words, you can say it's a judicious and effective use of energy to maximum profits. Or in other way, you can say minimize the cost and enhance the competitive position in the today's business scenario. This is what is called ENMS, Energy Management System. And what is the objective of the energy management system? To achieve and maintain the optimum energy use throughout the organization. At the same time, to minimize the energy cost without affecting production and quality. That is important. And ultimately, if you are going to reduce the fuel or if you are increasing the efficiency, definitely it will impact on the, it will minimize the environmental effects. These are the main pillars of any successful energy management. Topmost is the top management support is a must for any successful energy management. And for that, we require monitoring systems in place. And for analyzing this monitoring system output, we should have to have technical ability of your workforce. And based on this outcome, we should have to have strategic plan to modify or to go for the new technologies to achieve the energy savings. And it is all totally depending upon the people, their teamwork, and the standardization of our all processes. And this energy efficiency is extremely important to all the organization, especially those are energy intensive. Energy intensive means heavy industries like thermal power stations, cement industries, steel industries. Nowadays, government has also included all these railways. Even they have brought such type of industry under PAT target, that is perform, achieve, and trade. That we'll see in the next slides. You know, what are the energy management requirement? You should have an energy policy. Then you should identify the significant energy usage in your industry. Then you should have objectives and target to reduce your energy usage, and It's a action plan. Then any legal requirements. So this slide shows the philosophy of ENMS, Energy Management System. Here we'll see this is the policy, Energy Management System. For that policy, you should have a documentation. Then you should have an annual operating plan. And for achieving this annual operating plan, you should have a energy conservation initiatives. And you should have a monitoring to see the any daily deviations. And to reduce this deviation, you should have to have your control. And at our plant, we have our dedicated energy monitoring cell is there, which carry out the periodic audits. And we have a 25 energy auditors. You can see this is the policy. This is our energy management policy. And mainly it is signed by the topmost authority, that is station head, that shows the top management supports. Here we can say, here we are committed that the Dahanu thermal power station is committed to be one of the energy efficient electricity generating utilities. This is our vision, and our mission is to perform all the operations within the plant area efficiently, thereby conserving energy and the scarce natural resources, which in turn will minimize the impact on the environment. This is our energy management policy. And how you can achieve this, there are the various ways, like adopting appropriate energy efficient and clean technology in products, services, and processes having impact on the significant energy use in operations, maintenance, and procurement. Like this, there are various action plans, and that is committed or supported by the topmost priority. This gives our commitment to the environment and energy management systems. Now, every year you should have an annual operating plan. This is one of the examples. Your plant should have some targets, and based on this target, there is some weightage should be there, because all these targets you should achieve by the end of any. Like this, your plant availability should have an annual target of 96.04. Your planned outage should be less than 10 days. Your unplanned outages should be less than 4.5. These targets are set before the start of any financial year. And based on, this is the divisional targets, and based on these divisional target, all departments have their own targets in line with this divisional target, so as to achieve this all targets by the end of the financial year. So to achieve this, we should have energy conservation initiatives. I will show one of the example. This is the improvement plan taken by one of the department, that is operation department, to reduce the auxiliary power consumption of boiler feed pump by reducing the slip losses of hydraulic coupling by 5 to 7%. So every department has to take such initiative plans or improvement plans so as to reduce our energy consumption and to achieve the annual targets of AOP. This is the all these improvement plans are a part of our ERP package, that is SAP, and it has the approval levels up to station head, and whenever these are approved by all the authorities, they have to be implemented with the time frame. Then every day we are monitoring the daily energy deviations. These are the targets. There are some operational values, means the band is given for both units because of the ambient temperature variations. We should have to have one window, or you can say range. Within that they have to operate. If they exceeds beyond that, then we should notify that particular department because of which it is violating or it is increasing your energy consumption. On daily basis, we are monitoring this. For monitoring of various areas, and first of all, we'll see what objectives, why we should monitor. At the bottom, you can see the punchline. You cannot manage what you don't measure. Unless you measure or monitor, you cannot manage or you cannot control. So these are the objectives of any monitoring system. 100% monitoring of plant operations to identify the energy deviation in terms of heat rate, auxiliary power consumption, fuel consumption, to identify the energy losses in the system and improve efficiency. Reporting of these deviations through FIR. FIR means this is one of the process we are adopted in our SAP system, that which department has violated this energy deviation. We are raising the FIR through SAP system, and that particular department has to come up with the CAPA, that is corrective and preventive action, so as to avoid the recurrence of such deviation in future, to avoid the energy losses. One of the objectives is to provide the right information in right time at right level. Then data management for data collection and record keeping for the future uses, for the benchmarking or comparison, even our internal benchmarking. We have installed almost 250 energy meters at various auxiliaries, and all these are connected to a common server. And these are the for the continuous measurement of energy consumption. And all these energy meters are connected to ELAN system, and where all these process parameters like flow, tons per hour, or any processes, pressures, are hooked up to the common facility, where we are generating one report, and that report is auto emailed to the efficiency department to monitor these deviations on daily basis on auto in the midnight after completion of each day. And this report, energy, based on this report, energy deviations FIR are raised. We are carrying out this daily energy deviation report of various auxiliaries like boiler feed pump, condensate extraction pump, various ID fans, FD fans, coal mills, and we are identifying the deviations, if any, and necessary action plan to avoid these deviations. Based on this monitoring, there are various reports or MIS reports we are generating for the reviews, like daily energy deviation report, monthly building energy deviation report, monthly turbine heater performance, area-wise aux power, for identifying the areas where we are having some higher consumption, air ingress in the boiler, because boiler is always operating at negative pressure. So always there is a chance through various peepholes or any ducts. Quarterly insulation survey, because this boiler and pipings is having thermal insulation. We are carrying out the thermal insulation survey by our infrared cameras to identify the deterioration in the thermal insulation. Then we carry out the quarterly air leak survey to identify the instrument air leakages in the system and to arrest, and thereby reducing our auxiliary power consumption of compressors. Then we carry out the pumps and fans performance testing on periodic basis. Then for performance monitoring of heat rate, we monitor the boiler and turbine losses on daily basis. Auxiliary power consumption, individual auxiliary power consumption by online EMS. Then we have dedicated energy auditors which carry out the energy auditing of various areas as per CA guideline. Then for plant reliability, each and every tripping or event is analyzed and root cause analysis is carried out to avoid the recurrence. pre and post outage survey we are carrying out before overall, because our units, our boilers, they have to undergo annual overall on alternate years. So before overall or pre-outage, we carry out the pre-outage surveys to identify the area for improvement, which we cannot attend during our day-to-day operation while boiler is in service. We identify all these areas and rectify during our unit overhauling time when there is a boiler downtime, boiler down is there. And after completion of the annual overhaul, again we carry out the post outage survey whether that improvement is as per our pre-outage survey is carried out, or is there still any margin is there. So again that we come to know in our post outage survey. All this performance is reviewed at various levels in our daily departmental meetings with all the team members, in daily plant meeting with all the sectional heads under the leadership of head operation and maintenance, and on monthly basis with the plant head. For achieving this, we have defined the various roles and responsibility of the various operating staff. For example, boiler engineer should operate the boiler with optimum oxygen and minimum CO. These are one of the few examples which directly affects the energy usage. For turbine engineer, you should operate with optimum mainstream pressure. Local operator, detection of the steam, water, oil leaks. Maintenance engineer, overhauling, accurate measurement, calibration, replacement with energy efficient equipment. Chemist, we should maintain the water quality. Otherwise, there is a huge loss because of the continuous blowdown in the boilers. Coal handling, maintaining the proper coal blending, because we are using imported coal and Indian coal. Reduction in losses due to spontaneous combustion when we are storing the coal in the coal stacker because of the spontaneous combustion, because we have a seasonal jetty at Danu, which is not operating in rainy season, so we need to keep some stock. Then ash handling, maximizing the ash collection, and ADTPS personnel's optimum use of lighting, air conditioners, computers, waters. Then efficiency department is established in our station, and it is important to raise the FIR in SAP, that is ERP package, against any departmental process non-compliance. This is one of the example I can quote. This is the generation loss of 0.6 million units during unit 1 tripping due to both running coal mill strip. So this is the FIR on this boiler maintenance raised by the efficiency department. And to close this FIR, concerned department needs to implement corrective and preventive action to avoid the recurrence. This is the one of the corrective and preventive action taken by that particular department to avoid the recurrence of such event. And all these CAPA are approved or reviewed at various levels up to plant head. So this is again a screenshot of our SAP system where we are calculating the generation cost. And if you see this picture where you can see the fixed cost is only 12% and variable cost is 87%. And this variable cost includes the fuel cost, nothing else. How much you are paying for the coal and oil and DM water, that is affecting your variable cost. So from this picture, you will come to know that why you should need to control your energy usage, or why you should save your energy to reduce your generation cost, because 87% is our variable cost out of total. This 12% includes all our O&M activities, that is operation or maintenance of the plant, insurance, depreciation, even salary cost. But 87% is our variable cost, and that is fuel cost. So we need to control to minimize our generation cost and to become a competitive in the present scenario of the competency. So all these thermal power stations are operating under the regime of merit order dispatch. Merit order dispatch is nothing but the whoever the plant whose generation cost or variable cost is high, it is on the top of this list. And whenever there is a low demand in the system or in the grid because of the reduction in the demand, that particular power station has to reduce their output or to reduce their generation. So always our aim should be to minimize our variable cost. And you have seen that variable cost is totally depending upon your energy or your fuel. Then we'll see what type of the efficiency based maintenance. Now we have totally changed our philosophy from defect based to energy efficiency based, in which defect which affects the efficiency, auxiliary power consumption are given the topmost priority. For example, HP heaters, condenser, duct rectification, air preheater seals rectifications, mill performance, they are given the topmost priority whenever there is a opportunity to attend it. For this identification, we have a energy deviation report, equipment maintenance, improved plant performance, and reduce heat rate and auxiliary power consumption. This is the summary of our investment in energy saving projects and thereby saving in the last 3 years. Left topmost is showing the coal saving per year for the last 3 years. And right top is showing the energy saving, electrical energy saving in millisieverts of kilowatt hours. And the bottom left is showing the investment in the last 3 years. And right one is showing the financial impact in the last 3 years. This is one of the example of efficiency based O&M. We always keep more efficient equipments in service where there is a standby equipment. For example, if there are 2 pumps, boiler feed pumps, the most efficient equipment we always keep in service and other as a standby. And we carry out the reasons for lower efficiency, and accordingly we plan the maintenance during the opportunity. This is the one of the example of heat rate improvement by attending the partition plate in the regenerative heaters. This is HP heater, means high pressure heater. Before sending the feed water to the boiler, we are reheating this feed water by extracting the steam from the turbine piping to increase the cycle efficiency. In these heaters, there is one partition plate which bifurcates the inlet and outlet. Because of the erosion in the weldings of this partition plate, there is an escape of feed water from inlet to directly to the outlet. So without any heat pickup, it goes to the boilers, which affects our efficiency. So we identified all such type of deviations or area for improvements in our running condition and attending it during the opportunities. This is one of the best project we have carried out for the heat rate improvement. These are the 3 turbines: high pressure, intermediate pressure, low pressure, and we carry out the overhauling, and we replace the HP turbine with a refurbished one because over the period these interstage seals are deteriorating and this leads to the interstage leakage, and which reduces the turbine efficiency and ultimately affecting the heat rate. So there is a significant improvement after this by 59 kilocalorie per kilowatt hour. This is one in IP turbine. In unit 1, we have replaced with a new one, and thereby a improvement of 33 kilocalorie per kilowatt hour improvement in the heat rate. This is in unit 2. This is one of the best auxiliary power reduction project we have implemented by modified coupling in boiler feed pump. Nowadays, we are facing this part load because of the low load condition prevailing in the grid, because of the influx of more renewable energy in the grid. All these thermal power stations need to back down in the night hours or during low load period. So whenever there is a back down or low load, this boiler feed pump, there is a high slip losses in the hydraulic coupling. Most of you people may be aware of type of slip losses happening in the hydraulic couplings. So we have modified this hydraulic coupling with a modified gear ratio, and thereby we have been able to achieve 960 kilowatt saving just by replacing this hydraulic coupling, and with a payback period of only 6 months, which was costing 1 crore, including service charges. And after the successful implementation of this project, we have changed this hydraulic coupling in all 4 boiler feed pumps. This is the installation of VFD for the variable frequency drive for the condenser to extraction pump. And we have also D-stage, one of the impeller of the CEP, that is standby CEP. And because of this both energy saving happening in our both the units, we have reduced the auxiliary power consumption by installation of variable frequency drives to the various auxiliaries in the plant. And over the period, we have been able to save this million units of energy, electrical energy. This is our journey of energy efficiency over the period right from the 95-96 to till today, and this journey will continue. And this shows our commitment towards the energy efficiency. Over the periods, we have carried out various energy improvement projects. These are the mainly the significant project I have shown every year, what type of projects we carried out. Being this thermal power sector, these units are coming under PAT regime, that is perform, achieve and trade. We have completed 2 cycles of PAT, perform, achieve and trade, and wherein in first cycle we have achieved 4591 E-certs. E-certs is nothing but the certificates, energy saving certificates. It is depending upon the how much your annual heat rate achieved with respect to the target given by the Bureau of Energy Efficiency under the CEA, Ministry of Power. They give the targets to each thermal power station, and nowadays for the all steel industries, cement industries, and based on your performance, they issue the certificates, energy saving certificates. And even in the PAT cycle 2 also, this accredited energy auditor nominated by the Bureau of Energy Efficiency, they carried out the measurement and verification audit, and they have recommended 8749 E-certs for the Dahanu thermal power station. This clearly indicates our energy performance over the period. Now we'll see the coal management. Why it is important in our energy management. we have a 2 units of 250 megawatt, and we are using coal as a primary fuel. But the allocated that quota of raw coal with SECL, that Southeastern Coalfields Limited, was not adequate because of the gap between demand and supply of indigenous coal. So we started our importing the coal in 1998 to bridge this gap, and we started blending with the good quality and low ash imported coal with our Indian coal, which has given a significant improvement in our boiler performance, flame stability, and heat release by this operational philosophy. In this next slide, you can see what are the benefits received or obtained because of this adoption of imported coal at ADTPS. In 1995, we started our commercial operation with F-grade Indian coal with SECL, that is Southeastern Coalfields Limited. Over the period, in the first phase in 1999, we started blending the high GCV imported coal from the Indonesia with the Indian raw coal. And because of this initiative, there is a reduction in coal quantity, emission, clinkering in the boiler, and auxiliary power consumption. And this has improvement in unit load, flame stability inside the boiler, and ultimately improvement in overall performance. In second phase in 2001, we have stopped the Indian raw coal. Instead of that, we have established one coal washery at the coal mines in the Chhattisgarh, and we wash the raw coal to reduce the ash content in the coal. And we started blending of the washed coal with the medium GCV imported coal. And because of this initiative, there is improvement in the plant load factor, loading factor of the unit, plant reliability has increased, plant availability has improved, and there is a reduction in boiler tube leakages, equipment breakdown, failure of CHP, that is coal handling plant and ash handling plant auxiliaries, and thereby a reduction in the auxiliary power consumption. In the third phase in 2006, we stopped this medium GCV imported coal because of the high rise in the imported coal. So we started importing low GCV and medium GCV imported coal with the wash coal. And we have used this LCV coal as a partial substitute of Indian wash coal due to acute shortage of wash coal. Now we'll see some energy audit instruments which can be used in your energy audits to identify the various areas for the improvement. First one is used for the electrical measuring instruments, which measures the power kilowatt, then power factor, reactive power. And second one is the combustion analyzer, which has an inbuilt chemical cell and which mainly measures the gases like oxygen, CO, carbon monoxide, oxides of nitrogen, and sulfur. These are the portable equipments which can be used in the energy auditing. Then we can monitor the fuel efficiency by these instruments. O2 and CO2 measurement can be done by this fire rate measure instrument. Then contact thermometer. This is for the measuring the flue gases, hot air, hot water temperature by insertion of this probe into the steam. Then we can also use the infrared thermometer. This is non-contact type equipment which measures the temperatures, and we can identify the hotspots for the deterioration in our system. Then we can use this pitot tube manometer, mainly used for the air velocity in the ducts. Then we can also use this water flow meter. This is non-contact and ultrasonic type Doppler effect instrument which measures the flow inside the pipe. And we have a speed measurement. This is contact type and non-contact type. instruments, which mainly uses for the speed measurement. Then last one is the leak detectors, which detects the air leakages with the use of this ultrasonic technology, and which mainly unable to detect by the human abilities of ear. This is the lux meter, which indicates the illumination level at various places, and this shows the intensity of lighting to be required for the UR energy audit. This is one of the flow meters installed in our CW piping, and right one is shows the radar type level indicator, which we are using for the sea tide level, because we are using sea water as a cooling water for our condenser cooling, and depending upon the tide level, we are either switching on or switching off the cooling water pumps to optimize our auxiliary power consumption. Because whenever there is a high tide, there is sufficient amount of suction available for the pumps, so we can switch off the one of the pump and will be able to maintain our condenser vacuum with remaining pumps, and thereby reducing the auxiliary power consumption. Then we celebrate the energy week right during this month only. From 14 December is celebrated as an energy conservation day throughout the India. On that day, we have an energy conservation walk from our residential colony to the plant. On that day, no one is using the vehicle. It is around 2 kilometers between plant and colony. This is only to enhance the energy awareness about the energy conservation. And then we take a pledge towards energy conservation by all the ADTPS employees, including our station head at the administration building. Then in the colony area, we observe the earth hour. That is, we are switching off the electricity in the colony residences for 1 hour to make aware all these colony residents and children for the importance of this energy and energy saving. Then we carry out the various awareness program to the ADTPS family members. Then we carry out the energy quiz, e-quiz for all ADTPS employees, mainly based on the energy conservation and efficiency. Then also we conduct the energy conservation project competition for the school and colleges students. And also we plans ADTPS IPL, that is Interdepartmental Power League. In this, we carry out various interdepartmental competitions, mainly based on our questions on the energy conservation and efficiency. These are some of the snapshots of energy conservation week celebration at our plant. This is the energy conservation awareness at nearby schools and colleges by our staff to make aware the energy usage to our next generation. This is the drawing competition for the colony children's. Mainly theme is based on the energy conservation. This is for the colony ladies or residents. This is the interaction with the school students in the nearby Marathi medium and English medium both for the awareing energy conservation. This is interaction with the college students. This is the final award ceremony of our ADTPS IPL. Winners are recognized by the station head. Then these are the project competition for college students for the energy conservation projects. And station head is felicitating the winning team with the trophies. And all these efforts taken at ADTPS has received more than 100 national and international awards in the fields of quality, safety, environment, and overall performance of our plant. So here I will stop, or now I will switch over to students for any question or any doubt. Over to you, Amal sir.
Hello.
Yes, sir.
Now we can have some question answer session.
Yeah. Panaskar, sir. Please take the question from the participant.
Amal sir, is all these slides were visible, na?
Yeah. You are completely audible and visible throughout the session. No
Okay,
issues.
thank you. Because in the starting there was some technical problem at our end.
Panaskar, sir.
Hello.
Hello.
Thank you, sir. Indeed, it was a session filled with knowledge. Sir, now with your permission, I would like to take up the question answer session.
Yes, sir. Yes, sir. Definitely.
Okay. Sir, one question is from Professor Parmeshwar Paul. He is asking, what is the relationship between a country's economic growth with respect to the energy production and consumption?
Sir, in all these developing countries, there is always ever increasing demand of electricity. Because of this demand in electricity and our GDP growth, so always this ratio is on higher side. In all these countries where there is a developing countries, this ratio of energy to the GDP is always on the higher side. This reflects the demand of energy required to fulfill this growth.
Okay, thank you, sir.
Okay.
Any other questions from the audience? Okay. Thank you, sir. Now I will hand over to Amol, sir, for further discussion.
Okay.
Sir, one question I would like to ask. The technologies are changing regularly. So, how do you advocate the use of new technology products for on the production side? On the consumption side, like you said, CFL are coming. Then the earlier technology becomes very inefficient with respect to the new one. So, during the audit, where you take this during the preliminary stage or during the detailed audit stage?
Sir, actually, every year we carry out the energy audit through our in-house energy auditors. We have 25 energy auditors in our employees only. So we carry out the internal walkthrough audits through these 25 energy auditors, And over and above that, there is one mandatory audit is to be carried out by accredited energy auditor empaneled with Bureau of Energy Efficiency, and it is a legal requirement to all these energy intensive power utilities. So based on these, the outcome of all these energy audits, we go for these developments to reduce our energy consumption.
Okay.
And
Yeah.
and also we every year we participate in knowledge exchange platform organized by various utilities like CII or
Okay.
MEDA, then BE. All these utilities they organize the key exchange platforms for similar type of industries uh, to exchange the best O&M practices or innovative projects they carried out, so that same can be replicated to other industries in the larger interest of our nation to reduce the overall energy consumption in this type of particular industries.
Oh, thank you, sir. There is one more question, sir. It is by Professor Sanjay Geji. He is asking, is second law analysis carried out in the energy audit?
Pardon, sir?
He is asking, is second law analysis carried out in energy audit?
Second law, actually,
I
I'm
think,
not exact what
yeah,
is asking. Second law.
analysis. Okay, I think the question seems to be incomplete. I think so. Oh, okay, fine. So, okay, thank you, sir. We will. I will officially thank you. I will hand over to Amol, sir, now.
Okay, thank you, sir. Thank you.
Thank you, sir, for answering the participant question. Good afternoon to all. It is my privilege to propose vote of thanks on this occasion. I, Professor Amol Mangrukar, on behalf of MCT Rajiv Gandhi Institute of Technology, Department of Mechanical Engineering, and on behalf of organizing committee of AICT AQIS sponsored online 1 week short-term training program on recent trend in energy management and audit, and my own behalf extend a very hearty vote of thanks to Mr. Suhas Patil for accepting our invitation as resource person and sparing his valuable time with us. He has given good insight on the topic of energy audit and management, energy cost, energy performance measurement, energy audit regulation. Thank you, sir. So I would like to thanks to the participant. Thank you so much. So now I would like to request technical team to end the session, and the next session will be start at 2:30. Thank you to
Thank you,
all.
sir. Amol, sir.
Yes,
Thank you very much.
well.
Okay, sir.